Okay, I'm going to quickly work this out for you. You might need a calculator. It says find the next two expressions in the pattern shown, and then you would have to simplify all 5 expressions and then determine the value the expressions approach. Now the first one, after we simplify this, we should get 7/5. And you can try working these out on your own. You actually don't need to keep adding these over and over again. So basically you can take this part and then split 2 up into 1 plus 1 and substitute this part in. And then simplify this bottom up. And the next one would be 239 all over 169. Now if you use a calculator, it will be about 1.4. The next one will be about 1.416. You can also try dividing and then just round to the nearest 3 digits after the decimal, and you'll see this pattern, which I think is pretty interesting. And lastly, the last one will be 1.4142. So I just want you to get the idea of the concept behind this problem is just that if this pattern were to continue to grow, continue to go on, you'll eventually reach a value of square root of 2. Now let's look at how to solve rational equations. Now when you're solving rational equations, there are 2 methods. One is the cross-multiplying method and the other is the LCD method. And for both methods, you need to look for extraneous solutions, meaning solutions that cannot be the solution of the rational equation. And I'll tell you why when you come to this situation. So first of all, we can first cross-multiply. This will be x squared equal to negative x squared plus 2. And then this will be 2x squared equal to 2. X squared equals to 1. And by taking square root of both sides, you get x to be positive or negative 1 to be your solutions. Now we need to make sure that these solutions don't produce a 0 in the denominator, and if they do, it will be considered an extraneous solution in which you need to ignore. Now, in this case, these 2 solutions are fine. Now let's look at the next example. I'm going to first factor the denominator, so it'll be easier. Okay, now I can simplify the x, simplify the 3, and then I can cross multiply. I can simplify this. 3 equals x minus 3, x equals to 6, and you have only one solution. And again, if you substitute 6 back into the denominators, you won't get a denominator of 0. So 6 is not an extraneous solution that will give you a fraction that's undefined. And then next one. So combine the left-hand side of this equation, and now I'm going to cross multiply 2x and 5 minus 2x times x plus 3. We have 5x plus 15 minus 2x squared, and then minus 6x. So this would be 0 would equal to 2x squared plus 8x plus 3x actually, and then minus 15. And you may notice that this is not factorable, so we need to use the quadratic equation. And this will be 9 plus 120 over 4. And this would be your solution. Now, there wouldn't be any extraneous solutions because if you were to plug this in for x, it wouldn't give you a denominator of 0. Okay, now I'm going to show you the LCD method. So I'm going to multiply both sides by the LCD of x minus 2 and x plus 2. So moving on, we'll cancel out x minus 2 for the first term. Be x plus 2, and the next one would be 2 times both of these. So I could rewrite it as x squared minus 4. And this one, I would cancel out x plus 2. I'm left with 3x, x minus 2. Let's keep simplifying each side of the equation. Minus 8, 3x squared minus 6x. Okay, now let's see, 2x squared plus x minus 6. So minus 2x squared. Okay, and this would be minus x minus 7x plus 6. Okay, and then we have 1 and 6. So your solutions are 1 and 6. And now we need to double check if they're extraneous. If we substitute 1 here, it does not produce a denominator of 0, so it's not extraneous. And if we put 1 here, 1 plus 2 equals 3, it's fine. It does not equal to 0, because if you have something like this, then it can't be a solution. Okay, and we put in 6, same thing. It's fine. So we have 2 solutions. Okay, and now again, let's first factor the denominator. And then your LCD will be all of these factors, and if there's any repeating, we just use it once, such as x and x minus 3. Since the first term has both factors, so we can cancel it out when we distribute. So this will be 18, 6 minus 6, and then need an x here because we only have a factor of x minus 3. And this one, cancel out the x, so this is left with 5 times x minus 3. So x is 3. Now we've got to check if this is an extraneous solution. After you plug it in to this x, 3 minus 3, that is equal to 0. But 0 is in the denominator, 6 over 0. This is undefined. So we would say this is an extraneous solution. Therefore, we have no solutions for this rational function equation. Okay, and again, x times x minus 4, that's our LCD. cancel out the x for this one, and we have x minus 4, 10 times x minus 4. This next one takes both factors, and this one we cancel out the x minus 4, we're left with the x, so equal to x times x plus 9. Now let's simplify. We distribute the 10, let's distribute the 3x, distribute the x, and there we have. Okay, and then now 3x squared and x squared, 2x squared minus 9x, so this will be positive x. And then we have another one here, so this will be negative 11x. So minus 40 equal to 0. Now we need a factor, and we can use 2, 1, 5, negative 8. Let's check. 5, negative 16 makes negative 11 here. So we're ready to factor. 2x plus 5, x minus 8 equal to 0. So you have x equals to negative 5 over 2 and 8. And if you check your solutions, they won't produce a denominator of 0, so these are not extraneous solutions. Okay, this one is a little bit more complex. Okay, I'm going to first factor this part out, and it should be 2, 3, 1, 5. So 2x plus 1. Okay, this is 10, 13. So 2x plus 1, 3x plus 5. So then our LCD would just be 2x plus 1, 3x plus 5. Okay, and then now I can simplify or solve the rational equation. Next step will be 3x plus 5, x minus 3, plus 4x times 2x plus 1. And if you try factoring this, it's not factorable, so we just copy it. 7x squared plus 12x minus 20. Okay, now let's expand this using the folio method. So this would be 3x squared, and minus 9x plus 5x would be negative 4x minus 15, and then 8x squared plus 4x. Okay, let me first simplify the left-hand side. Okay, and this would be 11x squared minus 15. I can move it over. 4x squared minus 12x plus 5 equal to 0. Okay, now I'm going to use, let's see, 2, 2, negative 5, negative 1. Negative 2, negative 10, yay, negative 12. Okay, so let's factor. 2x minus 5, 2x minus 1 equal to 0. And x would equal to 5 over 2, and the other one will be half. Okay, to approach this next complex rational equation, I'm going to first simplify this part of the equation. Just like how I showed you how to simplify complex fractions. So 1 over x plus 1, and then 1 over 2 plus, I'm just recopying this. I'm going to multiply this by the LCD, x plus 1, 2, Okay, so cancel this. Okay, just put parentheses around this, and we'll multiply by this, cancel the 2. So you're left with x plus 1. And this one, you cancel x plus 1, you're left with 2x. Simplify, 3x plus 1. So I'm going to take 2 over 3x plus 1. I'm going to set it equal to 1 over fifths, and I'm going to cross multiply. 3x equals to 9, and x would equal to 3. And double check your denominator. If you plug in 3, 3 plus 1 is 4. 3 over 4 doesn't give you a 0 in the denominator, and you're fine. And this concludes part 2 of this lesson.